Hello and welcome to Thermochemistry, Heat and Work. Credits to slidesmania.com for this cute and aesthetic PowerPoint template. Let's proceed by solving this first problem related to heat. So how much heat was absorbed by a piece of silver weighing 362 grams with a specific heat of 0.233 joules per gram degree Celsius if the temperature increased from 300 Kelvin to 320 Kelvin. Let's write our given. So the mass of silver is 362 grams. The specific heat is 0.233 joules gram degree Celsius. And our initial temperature is 300 Kelvin. And our final temperature is 320 Kelvin. Do we need to convert this to degrees Celsius by subtracting 273.15? No, we no longer need to do so because delta K, or the change in temperature in terms of Kelvin, is just the same as delta degrees Celsius. Now let's write our general working equation. Q is equal to mCp delta T. Therefore, Q is equal to 362 grams times 0.233 joules gram degree Celsius multiplied with your delta T, which is 320 minus 300 Kelvin. So what is our Q? I'm giving you 5 seconds to calculate. Q therefore is 1686.92 joules. Looking at the sign convention, this is positive because your piece of silver absorbed heat. Now let's have another example. A piece of silver has a mass of 362 grams and has a heat capacity of 85.7 joules per degree Celsius. What is the specific heat of silver? So mass, and then your heat capacity. So what is our unknown? It is your Cp. This is in terms of joules gram degree Celsius. So how will we calculate for this? There is actually a very easy way on how we will have this value. It's simply dividing your heat capacity by its mass. Because looking at the units of your heat capacity and your mass and our required, this is the only procedure that we have to do. So let's do it. So what will be our Cp? Cp is 0.2367 joules gram degree Celsius. Did you get that? Okay, now let's proceed with our next video. For this next part of the video, we will be calculating for work. So for work, we have two working equations. It's FB and your negative P delta V. But looking at this problem, you have volume and you have pressures. Therefore, we will be using negative P delta V to calculate for this problem. Let's start with bullet A. So, a gas expands in volume from 26.7 to 89.3 ml at constant temperature. Calculate the work done in joules if the gas expands. So let's write our given for bullet A. Pressure is vacuum. this is almost equal to 0. If we write our work equation, it will be work is equal to negative 0 atm times our delta V. Therefore, our work will still be equal to 0 joules. How about B? It says here that your gas expands at a constant pressure of 1.5 atm. So let's calculate. And then we will convert this volume to liters. After that, we have to convert atm liter to joules. And our conversion factor is 101.325 joules per 1 atm liter. Therefore, what will be our work? Our work will be equal to negative 9.51 joules. And now let's calculate for your letter C. It will be the same procedure, but the value for your pressure will be 2.8 atm. So work is equal to negative 2.8 times the change in volume. Of course, this should be converted to your liters, multiplied by your conversion factor. Now, what will be our work? Work is equal to negative 17.76 joules. Now, you try to calculate for this problem. A certain gas expands in volume from 2 liters to 6 liters at a constant temperature. Calculate the work done in joules by the gas if it expands against a constant pressure of 1.2 atm. Did you get an answer? So the answer will be negative 486.36 joules, or it could also be negative 486.3766 joules, depending on the conversion factor that you use to convert atm liter to joules. So let's calculate it together. So your pressure is equal to 1.2 atm. Volume 1 is 2 liters. Volume 2 is 6 liters. Our formula is work is equal to negative P delta V. So it's negative 1.2 times 6 minus 2 liters. No need for conversion because this is already your atm liter. And we can immediately use your conversion factor, 101.325 joules divided by 1 atm liter. Therefore, work is equal to negative 486.36 joules. Is that clear? For questions, you may post them on the comment section below. Thank you very much for attending this lesson, and I will see you in the next video.